Here we're going to look at topic 76, example 2, solve a linear quadratic system using substitution. How can you use substitution to solve this system? So we're given a system of equations, linear quadratic, and what we're going to do is we're going to use substitution to solve this. So we know that y is equal to 3x squared plus 3x minus 5. So what I'm allowed to do is anywhere that there's a y, I can substitute or replace it with 3x squared plus 3x minus 5. So that's what I'm going to do. So we would do 2x minus, and then that y is going to become 3x squared plus 3x minus 5, and set that equal to 3. So all I'm doing is substituting. Now from here, I only have the variable x, so that tells me that I can use this to solve the equation for x, and then back substitute for y. So let's distribute this subtraction sign. So we have 2x minus 3x squared minus 3x plus 5, make sure you change all the signs, is equal to 3. Right, so let's combine like terms. So this 2x and the negative 3x can go together. So negative 3x squared minus 1x plus 5 will be equal to 3. Okay, continuing along. I'm probably going to wind up having to factor this. There's a couple things I'm going to have to do, but I do know that if I do want to factor, I need to have it equal to 0. So I'm going to subtract 3 from each side, which will leave me with negative 3x squared minus 1x plus 2, and that'll be equal to 0. I also know factoring, I really don't want this negative in front, so I'm going to divide everything by negative 1. And that will give me 3x squared plus 1x minus 2 is equal to 0. Okay, so now I can factor. I didn't do a very good job leaving space here. So 3x squared plus 1x minus 2 is equal to 0. We're going to need to use the AC method. So I need to multiply 3 and negative 2. So I need factors of negative 6 that have a sum of 1. All right, so negative 6 would be negative 1 and 6. 1, I'm going to write them all because there's not that many. Negative 2 and 3, 2 and negative 3. So this would be 5, negative 5, positive 1, negative 1. That's what I'm looking for. So those are my factors. Right, so we'll do 3x squared. I'm going to run out of colors eventually. Those are going to be my new factors in the middle. So I will put the 3x first because it's going to help me factor a little bit better. Remember, this is using the AC method. If you need to review, look up the AC method for that. So those two terms came from there. Now we're going to do factor by grouping. So we're going to look at these two. They have a 3x in common, so that'll be x plus 1. And then these two have a negative 2 in common, so we get x plus 1. Remember that these two here should always match up when we're using the AC method and factoring by grouping, which they do. So we'll write that as x plus 1, and then this 3x and negative 2 will get written together. So 3x minus 2 equals 0. Okay, so factoring is done. Now we can use the zero product property to solve. So x plus 1 equals 0, and 3x minus 2 equals 0. Solve each individual piece. So x equals negative 1. I'm going to add 2 here. 3x equals 2, divide by 3, and x equals 2/3. Okay, the bulk of the work is done. We have x, but we do need to figure out what y is. Okay, we don't quite yet know what y is, so we want to figure that out. To do that, we can take these x values and plug them back into either one of these equations. I'm going to choose the 2x minus y equals 3 one. It just will be a little bit easier. So I'm going to take 2x minus y equals 3, and I'm going to substitute -1. So that, again, I'm running out of colors. I use blue, red, orange, pink. Now we use pink again. No, let's not use the same color. We'll use this lime green. So this x equals -1, I'm plugging in here. So we get -2 minus y equals 3. I'm going to add 2 to both sides. -y equals 5. Divide by 1. So y equals -5. All right, so one of my solutions is -1, -5. Right, because that x value, that came from there, and then that y value. All right, I need to do the same thing. I need to do 2x minus y equals 3, but this time I need to plug in the 2/3 value. Let's use this brown. It's not really brown, but you get the idea. So that's going to go here. So we have 2 times 2/3 minus y. So it's going to be 4/3 minus y equals 3. This is wonderful. So -y would be equal to, let's fix that. What does this work out to be? So 3 would be 9/3. So let's write that. We're going to change that to 9/3 minus 4/3. So -y equals 5/3. This is an ugly problem. Divided by -1, y equals -5/3. All right, so in case you didn't follow that, I'm converting this 3. I'm just turning that into 9/3 so that I can combine like terms, so I don't have to use a calculator there. But if you have a calculator, just do 3 minus 4/3, you'll get the answer. All right, so that would be my second solution. So we would have 2/3 was my x value, and then my y value is -5/3. You can check that using a graphing calculator. You can check that substituting values back in. I am not going to check that because I've done enough here. But the idea is that we're going to use substitution. Everything that is done in this step you've done before at some point. You've definitely substituted, you've combined like terms, you've factored, you have used the zero product property, you've used the AC method, you've used back substitution to find your y values. So don't be overwhelmed by the sheer volume of the work on this specific problem. Just take it piece by piece or step by step and know that you know how to do all of this. You will get to the answer. It's just going to take a bit of time.